In the realm of astronomical exploration, few events capture the imagination of scientists and the public alike as the discovery of interstellar objects. These rare visitors from beyond our solar system offer a unique opportunity to learn more about the cosmos, its history, and the potential for life beyond our own planet. One such object, 3I/Atlas, has been the subject of intense scrutiny since its discovery in July. As the third known interstellar object to be observed, its trajectory, composition, and mysterious behaviors have intrigued astronomers worldwide. But recently, a significant breakthrough has occurred in tracking its path, a feat made possible by an unexpected tool: the European Space Agency's ESA ExoMars Trace Gas Orbiter. The discovery of 3I/Atlas, the Comet 3I/Atlas, made headlines in July when it was first detected as it streaked through our solar system at a speed of more than 130,000 miles per hour. Its speed alone hinted at its interstellar origin, as objects from outside our solar system typically approach at much higher velocities than those originating within. Scientists were quick to recognize the importance of the discovery, as it was only the third such object to be observed. The first, Oumuamua, made waves in 2017, sparking debates over its origins and nature, including wild claims that it could be an alien spacecraft. The second, 2I/Borisov, was more definitively identified as a comet, much like 3I/Atlas. 3I/Atlas, however, presents a host of unique characteristics that have piqued scientific interest. Initially, its surface appeared highly irradiated, suggesting it had been exposed to intense cosmic radiation, possibly from a distant star or other high-energy environments. Adding to the mystery was its anti-tail, a phenomenon where the tail of the comet seemed to be pointing in the opposite direction of the solar wind. This unusual feature led to speculation about the nature of the object, with some speculating that 3I/Atlas could be anything from a natural comet to an alien spacecraft. However, the consensus among most astronomers is that it is, in fact, a comet, albeit one with an exceptionally strange set of characteristics. The Mars flyby, a critical observation as 3I/Atlas made its journey through the solar system. It passed within close proximity to Mars, a flyby that occurred on October 3rd. This was a significant event because it provided a rare opportunity for astronomers to gather high-resolution data on the comet's trajectory and behavior. The ESA's ExoMars Trace Gas Orbiter (TGO), which was orbiting Mars at the time, managed to capture detailed images of 3I/Atlas as it sped toward the Sun. These images would prove invaluable, not only for understanding the physical characteristics of the comet, but also for refining its trajectory as it exited the solar system. Before this, astronomers were relying on data collected from ground-based observatories and Earth-orbiting spacecraft. While these instruments offered valuable insights, they were limited in their ability to track the comet's precise location and path. The unique vantage point provided by the TGO, positioned in orbit around Mars, allowed for a much more accurate assessment of 3I/Atlas's position. By triangulating the comet's location using observations from both Earth-based and Mars-based instruments, scientists were able to refine the object's trajectory by an impressive tenfold, vastly reducing the uncertainty in its future path. Triangulating the path, the role of Mars-based observations, the success of the Mars flyby in improving the accuracy of 3I/Atlas's trajectory is a testament to the power of collaborative space exploration. Using multiple observation points, much like how mobile phones are tracked by triangulating signals from multiple cell towers, astronomers were able to achieve a much clearer picture of the comet's trajectory. This approach, though challenging, proved to be incredibly effective. The data collected by the TGO allowed ESA scientists to refine predictions about the comet's exit path out of the solar system with greater precision than ever before. However, capturing images of distant objects in space using planetary orbiters is no simple task. The TGO's color and stereo surface imaging system, CASIS, was designed to photograph the surface of Mars, not objects in space. As such, capturing clear images of 3I/Atlas as it streaked past the red planet required precise coordination and calculations. In fact, this was the first time that data from a planetary orbiter had been accepted into the International Astronomical Union's Minor Planet Center database, which tracks the movements of near-Earth objects. This achievement highlights the growing sophistication of space exploration and the ability to use different instruments in novel ways to gather data on distant cosmic objects. The unexpected brightening and tail vanishing before its close encounter with Mars, 3I/Atlas, had already experienced some intriguing phenomena. One of the most notable events was a sudden brightening that occurred as the comet passed its closest point to the Sun on October 29th. Such brightening is not unusual for comets, which often brighten as they approach the Sun due to the heating effect causing the release of gas and dust. However, the timing and nature of the brightening were surprising, adding another layer of mystery to the comet's behavior. In addition to the brightening, 3I/Atlas underwent a temporary color change and a brief disappearance of its tail, a phenomenon that is not fully understood. While comets typically have a tail made of dust and gas that is pushed away from the nucleus by the solar wind, the tail of 3I/Atlas seemed to vanish for a brief period. This could have been caused by a number of factors, including changes in the comet's activity or a shift in the direction of the solar wind. Regardless of the cause, these events only added to the excitement surrounding the comet's behavior and its potential to provide new insights into the nature of interstellar objects. Looking ahead, future observations and insights with the trajectory of 3I/Atlas now significantly refined, scientists are eager to continue studying the comet in the coming months. The comet will make its closest approach to Earth on December 19th, when it will come within 168 million miles, 270 million kilometers, of our planet. While this is still a considerable distance, it provides an opportunity for astronomers to study 3I/Atlas in even more detail, using a variety of space-based instruments. ESA's upcoming Jupiter Icy Moons Explorer JUICE mission, which will pass through the comet's path later this month, is expected to provide additional data on the object. Similarly, NASA's Mars Reconnaissance Orbiter is preparing to release some of the most detailed images of 3I/Atlas yet, which could reveal even more about its structure and composition. Beyond these upcoming observations, the ongoing study of 3I/Atlas has broader implications for our understanding of the universe. The fact that this object is likely a remnant from a star system that was ejected billions of years ago offers a unique glimpse into the history of our galaxy. By studying its characteristics, scientists hope to uncover more about the processes that shape the formation of stars and planets, as well as the conditions that might support life elsewhere in the universe. Conclusion. The power of collaborative space exploration, the study of 3I/Atlas, represents a monumental achievement in the field of astronomy. It showcases the power of collaboration between different space agencies, spacecraft, and technologies in unraveling the mysteries of the universe. The success of the Mars flyby and the subsequent refinement of the comet's trajectory demonstrate how new and innovative methods of observation can lead to breakthroughs in our understanding of the cosmos. As 3I/Atlas continues its journey out of the solar system, it will undoubtedly remain a subject of fascination and study, offering insights into the origins of our galaxy and the potential for life beyond Earth.